Hello, nice to see you again on my channel. Today I have another amp dyno review for you, but this time I'm not going to a dyno Rockford amplifier. I have another amplifier from the mid-90s or early 2000s. This one is from Magnat and is called the 360 Classic. I had to fix this one because the channel 1 and 2 were okay, but channel 3 and 4 were distorted, sometimes no output, and I checked the idle current. It was around 0.7 amps, and that seemed that there is no output device defective. So I checked the input section and I found a broken RCA connection on the main board. It's rated 4 times 90 watts, but I don't know if RMS or something else, because we don't reach 90 watts into a 4 ohm load. Here are the RCA inputs for channel 1 and 2, and on the right side you have the RCA inputs for channel 3 and 4. 2 gain pots and also subwoofer filters, fixed subwoofer filters of 50 Hz or 80 Hz, and these subwoofer filters are for channel 1 and 2 and also for channel 3 and 4. Here you have the speaker terminals and the high level input and some fuses. And remember, if you want to connect the amplifier bridged on channel 1 and 2, you have to take the first from the left, the plus, and the minus from the second channel. This is the third seen from the left.
The 360 is connected to the dummy load, and now I'm going to test continuous power 1 kHz. All 4 channels are loaded with a 4 ohm load. That makes the value more realistic. If I only check one channel, the value of the voltage will be a little higher because there is less load to the power supply of the amplifier. 1 kHz test, applying input signal. That's it, I capture the signal and I get, scope says 21.6, I don't believe it, I will recheck this. Yeah, we can calculate with 21.2 volts. With 21.2 volts I measured an output power of 57.5 watts per channel into a 4 ohm load, all 4 channels driven. Now the same continuous power test, but this time with a 50 Hz signal. You see here 50 Hz. Scope says 20.8 volts. I go to the top of the waveform. I would say 20.4 volts. With a 50 Hz input signal, the amplifier still delivers 53.3 watts per channel into a 4 ohm load, all 4 channels driven. I tested the dynamic headroom capability of the amplifier, but there is no dynamic headroom. I just have a half volt more. Let's have a look at the amplifier's efficiency. I tested with a continuous power signal, 1 kHz, all 4 channels driven of course. Here you have the idle current, it's around 0.7 amps. 31.3 amps. The 360 has an efficiency of 53.6%. And now I switch to the 2 ohms test, and in this case I have 2 4 ohm resistors connected bridge to the front and bridge to the rear. Continuous power test 2 ohms, all 4 channels driven, 1 kHz. Stop signal input. Scope says 34 volts, that's not true. .32 volts. And with 32 volts the amplifier delivers 65.5 watts of continuous power into a 2 ohm load. 50 Hz input signal continuous power. Let me demonstrate the difference to the 1 kHz test. You can see the rail voltage is sagging in the clip. Here you see it. Not really clip, it's sagging here. With 1 kHz you have a clean clip, in this case not. So this amplifier is not very stable with the power supply. I fine tune to get a clean output signal. It's getting better now. We can take this one. And the voltage, as I mentioned before, is maybe the same. 29.4 volts. With 29.4 volts, the amplifier delivers around 56 watts. Into a 2 ohm load, all 4 channels driven with 50 Hz. And again, I demonstrate the clipping behavior with 1 kHz. I didn't show it before because I pre-adjusted it to make the video a little bit shorter. There you have clipping with 1 kHz. And now let's have a look at the amplifier's efficiency. If all 4 channels are loaded with 2 ohms, I use again my 1 kHz input signal, and let's go. We have 48.8 amps. The efficiency goes down to 39.2%. I'm not going to make a 1 ohm test per channel, never. The efficiency goes dramatically down, and we have a total output power of 262 watts if all 4 channels are loaded with a 2 ohm load. Now I'm checking for dynamic power. All cycles are at the same voltage level. Unclipped 0.8, so there is no dynamic headroom. Now I test short-term power with a 1 millisecond 1 kHz burst. And I will allow some kind of clipping. Oh yeah, there is some headroom. Oh, it's definitely clipped. Higher distortion. But the voltage grows. Even the clipped voltage, the maximum voltage is getting higher, so I cannot crank it up a little more. Let's take this clipped signal, that's the max voltage, and then we have, let's calculate this 42 volts. With this dirty signal in the scope, I squeezed out 113 watts out of the amplifier for just 1 millisecond. So test with 8 cycles. I take a single shot. You see it. The first one is okay and higher, the second and the third go down and clip. I will reduce the gain until I have maybe little cleaner cycles. It was way too much. So we have the second one which is clean. We have some more clean. There are several ways the manufacturers test their amps. So here we have almost clean signal. Let's have a look at the last one. Still clipped. I will reduce until it's unclipped. Still clipped. And let's allow this one. And let's check out if all the 8 cycles are at the same voltage level. This is what I always do. So I go down and check the line. Well, they are at the same voltage level. And then we have a voltage of 32.48 volts. With 8 cycles, I squeezed out 67.4 watts out of the amplifier. This is what I call a real cheater amp, because we will never reach 90 watts by 4 at 4 ohms.
time. Thanks for watching.